A warm welcome to all of you from my workshop. Today, I'm going to show you an experiment. Specifically, we'll be looking at the Coherer detector, which, among other things, laid the foundation for the first spark telegraphs. Wireless telecommunications started to take off towards the end of the 1890s. The Coherer detector was invented in 1890, and later Marconi saw it and built a radio receiver from it. This is how it all began. This was a kind of wireless radio that transmitted Morse code. In 1890, a French physicist experimented with iron filings. He scattered the iron filings and measured their resistance. Then, when these iron filings were exposed to radiation, their resistance changed. Later, Marconi was able to build a receiver from this. A very basic and simplified model of this receiver can be seen here on my table. The receiver also came with a transmitter. Back then, the transmitter was a spark. There was a large electric spark, which somehow radiated out into the air, reached the receiver, and the receiver had to pick it up. The early receivers had a range of about 600 meters, but by the early 1900s, such a device could bridge up to 3,500 kilometers. Morse code itself had already been around much earlier, were already in use in 1837, since this was the form of communication used on wired networks. In 1865, Morse code was standardized, and what's interesting is that for a very long time, no changes were made to the Morse alphabet. But in 2003, they did make a change and added the @ sign, because of internet email addresses. This type of Coherer detector receiver was only used until 1907 because reception was disturbed by many things, and the device wasn't particularly sensitive. This detector is incredibly simple. Just imagine you pour iron filings or iron shavings into a glass tube, seal both ends, insert an electrode into each end, and when this iron powder is exposed to radio waves, it conducts electricity better than when it's not exposed to radio waves. From 1907 on, they generally used crystal detector devices. On the Titanic, they used this to send the SOS signal, and also to receive the SOS signal. There are rumors about what exactly SOS stands for. The most likely version is that it means save our ship. Since we're talking about the SOS signal, I'll also mention that since 1906, SOS has been the International Distress Signal. Before that, it was CQD, which stands for Come Quick Danger, meaning come quickly, there's danger. I drew on a piece of paper. I'll show the detailed electrical wiring diagram of this whole thing up close to the camera. This wiring diagram is actually extremely simple to follow. This specific part here is by far the most interesting, which is the Coherer detector. For example, you can build the Coherer detector yourself by taking a standard glass tube fuse, carefully removing the inner wire, grabbing a solid piece of iron like this one, and a metal file. As a direct result of doing all of this, we'll have a whole bunch of small iron filings and iron shavings, just like what's inside this box here. You will need to carefully fill the entire inside of the glass tube fuse with these iron filings. Of course, before doing that, you have to remove the original fuse wire from it. I have tried to draw that process here. So this is a standard glass tube fuse, and inside it is the iron powder. The detector has 2 points, here and here, 2 electrode points. In my example, I connected 2 9-volt batteries to this detector. And here I built a small relay. If a spark comes, it starts conducting electricity. About 15 milliamps will flow, the relay will pull in, the relay will switch, and a second circuit will start up. Here you can see the fuse, which has iron filings inside. Here is the wooden rod I mentioned, which is represented by this black hatched thing in the diagram. And here is the relay. The 2 9-volt batteries are here, along with a switch. The coil is visible here, and this is what can strike the wooden rod like this when the magnetic field is activated. The 4 4-volt lithium-ion batteries are shown here, although it might be more accurate to call them 3.7-volt batteries. In any case, there's 16 volts here now, and there's also a switch here. The device also comes with a bell, a small dome like this, which can be placed here, like this. And when I transmit a specific electrical signal with my telegraph, the tiny individual iron particles located right here will align as a result. Consequently, they will conduct electricity. The coil of this relay will be activated, and because of that, this component will move exactly like this, just as I'm pressing it now with the skewer stick. When this piece moves here, so this happens, it closes this circuit, then this heavy iron rod will go up and strike this wooden rod from below, like this. After that, these particles become disordered once again, and as a result, they will conduct electricity much less than they did before. This process will release, returning to this original state. And while this happens, there will also be a little ringing sound, because this rod will strike the small bell. In short, what will happen is that there will be a spark, a bright electric spark, and as a direct result, a little bell will ring right here. It's filled with fine iron powder. It has two electrical terminals. One wire is connected to one terminal, the other wire to the other terminal. This is the antenna for the whole system. I turn on the receiver with this switch, and in the first experiment, I will use the spark from this gas igniter. It has a small piezo ignition, and here at this little white part, I hope it's visible on camera, this is where the spark is generated, and the outcome will be, watch closely, the relay will engage here. So what will happen is that it will move. Let's see. You saw it. The relay engaged. And as I mentioned, to release the relay, you have to tap it, and the relay returns to its default position. Let's see again what happens. So the relay is in its default position. Here's the gas igniter in my hand. I fire the piezo part, and when I fire the piezo part, the relay engages. This circuit is not active yet. It's currently turned off. I push this back, and then you can see there's a little black switch right here. It's currently in the off position. Now, I'm going to activate this specific part of the circuit with this switch, the bigger one I showed you here. And inside this electromagnet, there's a piece of iron, and when it hits the piece of wood, watch the lever very closely. It returns back to its original starting position. Now I have turned on the electrical circuit, and it is the same story as before. I fire the piezo igniter, so let's see exactly what happens. It was really incredibly fast. You saw that it rang just once. The relay engaged immediately, and as a direct result, it hit the wooden rod, and the whole mechanism reset itself to its original position. Let's try that once more. Let's do it once more. I also made a transmitter. This here is a car's spark plug. One wire is connected to one terminal of the spark plug, and another wire to its ground. I'm going to try to radiate the electromagnetic waves generated by the spark plug. This is the ignition coil, obviously from a car, and this is the ignition cable from a car. This is the battery, which you can see here on the screen. This component is now actively providing the necessary electrical power for the ignition coil. Let me show you exactly what will happen next. Here in this view, you can see that the spark plug is consistently producing bright sparks. Right here, you can observe the receiver device in full operation. The continuous sparks are coming directly from that specific spark plug. Here, these two individual wires. This is the antenna. It picks up the incoming electromagnetic waves, leads them directly here to the detector, and then the detector starts switching this relay. When the relay switches on, this iron rod strikes the bell. The metal particles inside realign, and the physical conductivity stops. If I only send a few impulses, there will only be a few rings. Let's see how this entire process works in action. If you want to build it yourself, here are a few helpful and practical suggestions. This coil should be positioned on a possible track, so that the iron rod can slide back easily when there is no current flowing through the coil. You need to set the end of the wooden rod so that it aligns itself perfectly and precisely with the end of the metal rod here, so it can strike it effectively. That is one of the most important tips I can offer you. My other tip is that this wooden rod should be installed in a very loose and flexible manner onto this little tower. I just positioned it right on top. I didn't even screw it in, so it unsteadily wobbles both this way and that way. This little bell only produces that distinctive ringing with that tinkling sound if there's some metal at the end of the wooden rod. I glued a size 5 or 6 nut right here. This mechanism isn't tilted because it's drunk, but rather so that gravity always keeps this little tongue perfectly vertical. When the mentioned 15 milliamps of current flows through this coil, then the powerful electromagnet pulls this little metal tongue over. There is a flat iron plate located here, covered with thin aluminum foil, which is exactly why the electromagnet can move this little tongue. Now I have turned it on with a manual switch, and with the help of the long wooden skewer, I gently nudge the tongue like this. When I nudge the tongue, the electrical circuit closes, and as a direct result, it strikes the wooden rod. Wire, metal powder, a small glass tube, and a little ringing bell. With a screw and a few small parts, you could make this kind of ancient receiver. Of course, it's not used anymore because it's outdated, but back then, without any kind of transistor, this receiver was capable of a very slow data transfer speed. Nowadays, many households already have gigabit internet, but it's good to know where we were 130 years ago. This is where we were. This was the data transfer speed. Back then, this was a really big deal, a huge innovation. I am truly glad that you joined me today. And if you like my video, as usual, please consider giving it a thumbs up and subscribe to my channel. Thank you very much for watching. Bye!